Hi, and welcome to our first lesson on rational expressions. First thing I'm going to have you do is fill out this table on this page so we can talk about it. So I'm just going to pause the video, fill it out, and you can check yours against mine. Alright, so there's our table all filled in. And the main thing we want to talk about here are these times when these rational expressions are undefined. Okay, basically that's just going to happen when our denominator is 0, or the bottom is 0 basically. So for question 2 it says, what observations can you make about the allowable values of the variables in these expressions? And what we need to make sure is that for number 2 the bottom doesn't equal 0. Or else we'll end up with one of these yellow undefined cases. Okay, and now let's just take a second to have a look at what a rational expression is. So a rational expression is basically a polynomial over a polynomial. Hopefully you know what a polynomial is from previous grades. It's basically anything with variables taken to any power, any like 1, 2, 3, 4, 5, 6, any natural number power. So for example, 2 to the power of x, that's not going to be a polynomial, so that's not a rational expression. If we have a square root, that's x to the power of a half, that's not going to be a rational expression. So it has to be like, say, x squared, x to the power of 1 we have there, and we're going to have like x to the power of 1, y to the power of 1. That's also fine. And next here is a summary of the stuff we learned on the first page. Basically says that the bottom can't be 0. So for this rational expression, if I put in x equals 3, the bottom would be 0. So we need to basically say that just x can't be 3. Alright, so let's have a look at our first example out of the book about non-permissible values. Like we said, we don't want the bottom to equal 0. So if this is true, then we have a non-permissible value. Easiest way to find out what values of x will make that equal 0 is to factor it. And that we get x minus 3 times x plus 2 equals 0. So if x equals 3, or if x equals negative 2, then the bottom is going to equal 0. So we would have to say, normally we put comma, x can't equal 3 or negative 2 right there. And we'll do the same thing for part B. We'll see when the bottom equals 0. And let's subtract 1 from both sides on this. And I get x squared equals negative 1. Well, no value of x is going to make that true, so this has no solution. Doesn't matter what real value of x we put in, the left side will never be negative. So in this case, we just wouldn't have anything here. Any value of x we put in isn't going to give us a division by 0. So we can use any value of x we like. Okay, equivalent expressions. An equivalent expression is basically something that's going to act exactly the same as the original for all permissible values. Okay, and it should also be said that it should have the same permissible values as well. So in example 2 here, they want us to use multiplication and division to write two equivalent forms of this. So first thing we need to do is figure out the non-permissibles for this. So I've got x plus 2 times x minus 4, and I want to find out when that equals 0. Well, that's going to happen when x equals negative 2 or when x equals 4. So first thing I need to say is that for this expression, x can't be negative 2 or 4. Okay. The first most obvious way of creating an equivalent form here is to see that x plus 2 over x plus 2 equals 1 over 1 if x can't equal negative 2. If x equals negative 2, then we get 0 over 0, and that's a mess. And we don't want to talk about that at all. It's not going to be defined. So if x doesn't equal negative 2, then x plus 2 over x plus 2 is going to equal 1. So an equivalent expression would be 3 over x minus 4. And then we also still have to say, though, that x can't be negative 2 or 4. So because we couldn't put negative 2 into our original, we also can't put negative 2 into this equivalent expression, or it won't be equivalent. Okay. Another thing we could do is, let's take our original here. And we've got x can't equal negative 2 or 4. Oops, that didn't need to be so high. And one thing I could do with it is say multiply it by 2 over 2. So that could give me 6 times x plus 2 all over 2 times x plus 2 times x minus 4. And we still need to say that x can't be negative 2 or 4. Notice no matter what value I put in for x into this guy, it's going to come out to be the same value as it would be for that guy, because the 2's are we're just going to end up with 2 over 2 as 1. Okay. Notice one thing we can't do is I couldn't go, so here let's throw our original up here. Notice something I couldn't do is I couldn't say multiply that by x over x, because then the expression would have to be x can't be 0 or negative 2 or 4. So for when x equals 0, it's not going to have the same value as the original because it won't be defined. Okay, and as you've probably already guessed, on the last page, we're never going to multiply anything by 2 over 2. It's just going to make it more complicated. What we're going to do is try to make things less complicated. So we're going to simplify things. So if we want to simplify this rational expression, first thing we need to do is find the non-permissibles. Well, if a equals 0, I'm going to end up with division by 0. And also if b equals 0, I'll end up with division by 0. So a can't equal 0, and also b can't equal 0. Okay, and then same as reducing a fraction, we're just going to divide top and bottom by the same thing, and we're just going to look at each thing separately. So probably the easiest way to do this is to, actually, let's just do it right on here. So I've got 25 over 35 is the same as 5 over 7, because I can divide top and bottom by 5. A cubed over a, if I divide top and bottom by a, that bottom a goes away, and that turns into a squared. Divide top and bottom by b squared here, and I'll end up with just a 1 there instead of the b squared. B cubed on the bottom, and there's nothing I can do with the c. So I end up with negative 5 over 7 a squared c all over b cubed. And notice that still a can't equal 0 and b can't equal 0. Okay, good way to check these is just choose values for a, b, and c. Plug them into the original, make sure that the new one also has the same values. So for example, if I put in a equals 1, b equals 2, and c equals 3, if I put that into my reduced form, I'm going to end up with negative 15 over 56. And if I put it into the original up top, I'm going to end up with negative 300 over 1120. Which, if I divide top and bottom by 20, I find out is the same as negative 15 over 56. So we're good. Okay, so again, for the check, just choose a value. Obviously, you need to choose values where a, b, and c are defined. Throw them into the original. Throw them into the new one. You should get the same value, because that's what equivalent means. So for part B here, first thing we need to do is our non-permissibles. The only problem we're going to have is if x equals 0, so we just have to say that x can't be 0, so we don't have a division by 0. Okay, now I'm going to factor the top. So I'll have a 6x times x plus 2 all over 3x. So I get 6 over 3 is the same as 2 over 1. And because x can't be 0, x over x is the same as 1 over 1. So I've got 2x plus 2, and x can't be 0. And again, let's do a quick check. If I throw in x equals 1, in the original, I get 18 over 3, which is 6. And on our new one, I get 2 times 3, which is also 6. So for x equals 1 at least, these two expressions are equal. And that's a pretty good check to see whether or not they're equivalent. Okay, so for C, going to have to do a little bit of work to get our non-permissibles. Let's find out when x squared minus 5x minus 14 equals 0. Notice you should always just factor these, because you're going to need to factor them to reduce them anyways. Oops, that's a 2. So if x equals 7 or negative 2, we're going to have problems. So I'm going to say that x can't be 7 or negative 2. Okay, and now I'm also going to factor the top. That's going to give us a better chance of reducing things. So that's the same as x plus 7 over x minus 7 using difference of squares. And that's all over x minus 7 times x plus 2. Okay. Notice that we can only cancel stuff out, reduce stuff top and bottom, if things are multiplied together. So in this case, we've got x plus 7 times x minus 7 and x minus 7 times x plus 2 on the bottom. And because x can't equal 7, x minus 7 over x minus 7 is the same as 1 over 1. So our reduced form is x plus 7 over x plus 2. And we actually don't need those brackets there. Knowing still that x can't be 7 or negative 2. Okay, and again our check. In our original, if I throw in x equals 1, I get negative 48 over negative 18. And if I throw x equals 1 into our new guy, I get 8 over 3. And notice that if I divide top and bottom here by 6, I find out that those are equal. So they're equivalent. All right, let's have a look at D here. So first thing we need to do is our non-permissibles. So let's check and see when 9 minus x squared equals 0. Well, that's going to be 3 minus x. Oops. 3 plus x equals 0. And that's going to be true when x equals 3 or negative 3. So we know x can't be 3 or negative 3, or else we'll have division by 0. Okay, and now to simplify the top, we're going to have to factor that as, or sorry, to simplify the whole thing, eventually we're going to have to factor the top. So let's have a look at factoring the top there. That's 2x squared minus 5x minus 3. We need two numbers that add to negative 5, multiply to negative 6. So that gives us 2x squared minus 6x plus x minus 3. Factor out a 2x. And that's just a 1 factored out. You don't need to write anything there if you don't want to. We pull the x minus 3 out, and we're left with 2x plus 1 inside the brackets. So the top is going to be x minus 3 times 2x plus 1. And we're going to have 3 minus x over 3 plus x. Okay, well, we don't have anything exactly the same, but geez, these guys sure feel like there should be something we can do with them. And actually there is. Notice that they're the same if we multiply one of them by negative 1. So what I'm going to do is I'm going to factor a negative 1 out of the top guy there. So that leaves me with negative 1. So that'll be negative x plus 3 all over 2x plus 1, 3 minus x, 3 plus x. And now notice negative x plus 3 is actually the same as 3 minus x. So because x can't equal 3, that's the same as 1 over 1. So our reduced form is going to be negative 2x plus 1 all over 3 plus x. And actually, we'd normally write that as x plus 3. So let's write it that way. And x still can't equal 3 or negative 3. Okay, and our check, if I throw in x equals 1, I get negative 6 over 8 in the original, and I get negative 3 over 4 in the new one. And just by dividing top and bottom by 2, we can see that those are equivalent fractions. Okay, so again, notice the only reason why we could see that this was the same as 1 over 1 is because everything here is multiplied together. And by that I mean the negative x plus 3 and the 3 minus x. Okay, and let's just kind of re-examine that idea at the bottom of the page here. So notice that x plus 7 over x plus 1 cannot be simplified to just 7. Okay. Yeah, let's just prove that, yeah. So let's do our standard check here. We put in x equals 1. So that would be 1 plus 7 over 1 plus 1 is going to give us 8 over 2 equals 4. And clearly 4 and 7 are not the same thing. Okay, so notice we can only simplify stuff when things are multiplied together. So here we've got 7 times x all over x. X can't be 0. In that case, x over x can equal 1 because everything's multiplied together. Okay, so because x isn't 0, it's not going to be 0 over 0, so we can just simplify it to 1 over 1. So 7x over x, when x can't be 0, is equivalent to, that 3-line thing is equivalent to 7, given that x isn't 0. Okay, and notice our check with 1 works. If I throw in x equals 1 in the first one, I get 7 over 1. And of course, if I throw in x equals 1 in the second one, it does nothing. It just gives me 7. Okay, so really, really important. You can only cancel things up and down, top and bottom, when things are multiplied together.